Hello students, let us start another important chapter, statistics. It is not a new topic for you since you have learned related concepts on statistics right from class 6. You had a chapter called as data handling in class 6th and 7th, and in class 9th you had statistics. You have learned the methods of finding mean, median, mode, that's called as central tendency. We shall not get into the previous knowledge like what is collection of data, what are the two different types, primary data, secondary data, how to organize the data, how to represent the data. We will not discuss that. However, I would like you to revise and recall certain concepts which you had learned in class 9th that would help us in identifying the new topics of class 10th. In class 9th you had ungrouped data. First, let us recall certain important topics related to statistics, related topics of statistics. Terms related to statistics. The first one is data, the collection of information in the form of a numerical figure regarding different aspects of life is called data. The data can be about population, birth, death, temperature of different places, marks scored in a class, runs scored in different matches, etc. We need to analyze this data. For example, look at this table. It gives the number of students opting different activities. The activities mentioned here are dance, music, art, and sports. The number of students with respect to dance is 15, with respect to music is 25, with respect to art is 10, and with respect to sports is 40. When we collect the data, we just collect it randomly, and that data is called as a raw data. When some information is collected randomly and presented, it is called raw data. For example, here are the marks obtained out of 25 by 20 students of class 7th A in a maths test. They are mentioned here. These marks are just written at random. So this particular data is a raw data. This data is also called as observation. Each entry collected as a numerical fact in the given data is called an observation. Whenever we arrange the data, we get array. Array means the raw data when put in ascending or descending order of magnitude. It's called as array or arrayed data. For example, data when written in ascending order in the previous example, it becomes in increasing order. This particular thing is called as array or arrayed data. Recall, we also had a concept related to range. The difference between the highest and lowest value of the observation is called as a range. For example, if the highest marks obtained is 20, lowest marks obtained is 4, the range will be 20 minus 4, which is 16. Remember, we also had learned the definition of a mean. It is calculated by dividing sum of all the observations by the total number of observations. If x1, x2, x3, so on till xn are n observations, then sum of those observations divided by n is also given by sigma xi divided by n. For example, the height of 10 girls were measured in centimeter and the results are 142, 149, 136, 148, 129, 140, 148, 145, 150 and 133. To find the mean height, we need to add those heights and divide it by total number, that's 10. Upon addition, we get 1420 divided by 10, we get 142 centimeter. This particular data, whichever is discussed till now, it's all called as ungrouped data. For ungrouped data, we also have learned finding mode, which is highest repeated observation. Also, we have found median. Now let us take up a small concept called as frequency distribution of grouped and ungrouped data. First, let us take up frequency distribution of ungrouped data. Let me give an example here. If 20 students in maths test, out of 25, the marks obtained are say 21, 23, 19, 17, 12, 15, 15, 17, 17, 19, 23, 23, 21, 23, 25, 25, 21, 19, 19 and 19. These are 20 students' marks. Whenever we mention as a table, we first look at the number and we make tally mark. If 12 is written at only once, one line indicates one frequency. Frequency means the total number of observations. Here, frequency 2 refers to the observation 15 repeated 2 number of times. Here we have got 19 as the maximum repeated observation. There are 5 19s repeated. This particular table, which gives observation, tally mark and the frequency, is called as frequency distribution table. Let me take up a group data. The presentation of the previous data, when expressed in terms of groups, these groups are called as the classes are the class intervals. And each class interval is bounded by 2 figures. They are called as class limits. For example, the marks and the number of students of previous example, if I take from 0 to 10 marks, no student are there. From 10 to 20, there are 11 students. From 20 to 30, there are 9 students. So here, the same information is being given in terms of the class interval. Note that the lower value of the class interval is called as a lower limit and the upper value of the class interval is called as upper limit. Thus, A class interval has lower and upper limits. For example, in class interval 10 to 20, 10 is called a lower limit, 20 is called an upper limit. Remember, in class 9, we also had this type of a grouped frequency distribution table, and we had defined inclusive type and exclusive type. So what is this inclusive and exclusive type? Let me take up exclusive form of data. In this, the class intervals are 0 to 10, 10 to 20, 20 to 30, and so on. In this, we include the lower limit but exclude the upper limit. So 10 to 20, this means that the value is from 10 and more but less than 20. 20 to 30 refers to the mean values from 20 and more but less than 30. In the inclusive type, it is slightly different. For that, I'll take an example. Let the marks obtained by 20 students of class 8 in a test are 23, 0, 14, 10, 15, 3, 8, 16, 18, 21, 3, 20, 23, 24, 15, 24, 22, 14 and 13. These are 20 different marks. Let's arrange this particular data in terms of an inclusive form. So I will take 0 to 10. Next, I'll take 11 to 20. Next is 21 to 30. Here, between 0 to 10, there are 6 number of students. Here, main important thing is the 10 is included in this. Here 20 is included in the second class and the 30 is included in the third class. Here we arrange the data in different groups. The class interval 0 to 10, 11 to 20, 21 to 30. 0 to 10 in this inclusive type, it means the number is between 0 and 10, including both 0 as well as 10. Here, 0 is the lower limit, 10 is the upper limit. 10 to 20, it means between 11 and 20, including 11 and 20. Here, 11 is called the lower limit and 20 is called as upper limit. The data is expressed in the inclusive type. It is converted to exclusive just by subtracting 0.5 from upper limit, subtracted from the lower limit and added to the upper limit. So in the class 11 to 20, if it is in inclusive type, to change into exclusive type, we subtract 0.5 from 11, it becomes 10.5. When we add 0.5 to 20, it becomes 20.5. Similarly, 21 to 30, we take it as 20.5 to 30.5. What are the class limits in inclusive and exclusive form? Here in particular, we see the class limits and the class boundaries in both inclusive and exclusive type. We will also discuss the class interval, class mark, and range of the data. Let us take up class limits and inclusive and exclusive type. In the inclusive form, The lower and upper limits are known as true lower limit, true upper limit of the class interval. Thus, the class limit of 10 to 20, the class interval in the inclusive form are 9.5 to 20.5. In the inclusive form, the class limits are obtained by subtracting 0.5 from the lower limit and 0.5 to be added to the upper limit. From 19 to 20, in the inclusive form, it will be 9.5 to 20.5. Let's take up class size. The difference between the true upper limit and the true lower limit of the class interval is called as a class size. The class size will remain same for all the class intervals. For the class interval 10 to 20, the class size is 10. If we take the upper limit and add it to the lower limit and then divide it by 2, will give us class mark. The mid value of the class interval is called as a class mark. Class mark is also given by half of upper limit plus lower limit. For the class interval 10 to 20, the class mark will be 10 plus 20 upon 2, which is 15. Let us recall what we had learned in class 9, that is mean. Mean or average or arithmetic mean is one of the representative value of data. We can find mean of observations by dividing the sum of all observations by the total number of observations. Mean of the raw data, if x1, x2, x3, so on until xn are n observations, then mean is given by sigma xi on n. This sigma is a symbol, Greek letter, it shows the summation. Whenever we have a tabulated data, if x1, x2, xn are n observations and the corresponding frequencies are known, to find the mean, what we do is we will add up the product of fi and xi. So it is sigma fi xi upon fi. Let's understand this with a set of example. A die is thrown 20 times and the following scores were obtained and recorded. Prepare the frequency table of scores on upper face of die and find mean score. For that, I'll make a tabular column. I'll consider the number of upper faces of die and the number of times it occurs. The number on the upper face is represented as xi. The number of time it occurs as fi. The product, I'm going to find it. Here 1 is repeated 2 number of times. So 1 into 2 will give fi xi value. Same way, 2 repeated 2 times, 2 times is 4, 3 repeated 5 times, 5 times is 15, 4 is repeated 1 time, it's 4, 5 is repeated 4 times, it is 20, and 6 is repeated 6 times, it is 36. Here, to find the mean, I'll consider sigma fi xi upon sigma fi. We will add them up and find the value. We get it as 4.05. Let's look at another question. If the mean of the following distribution is 9, find the value of P. X represents the observation, F represents the frequency. Here, the value of P has to be found. So I'll make a column like xi, fi, the product. 4, the frequency with respect to 4 is 5, so fi xi will be 20. Same way, 6 repeated 10 times, we get 60. Similarly, p plus 7 repeated 10 times, we get 10 times of p plus 7. 10 is repeated 7 times, it is 70. 15 is repeated 8 times, it is 120. What we do is, we'll find the sum of frequencies. It's 5 plus 10 plus 10 plus 7 plus 8, and the total becomes 40. And we'll find out the sum of fi xi. Here, when we add the numbers, we get it as 270 plus 10 times of P plus 70. I have just multiplied it. Mean will be sigma fi xi upon sigma fi. So mean is known. It is 9. So find the value of P. We get it as P equal to positive 2. So it's very easy to find mean of the observation if it is ungrouped data. If we have a grouped data, while calculating, we follow different methods. We have the method called as direct method. Direct method. We have assumed mean method. We also have step deviation method. These are the 3 different methods which can be employed in finding mean of the group data. Let me take up an example to show. Here there are number of plants and the number of houses which are given in a tabular form. If you want to find the mean number of plants per house, what we do is we follow these steps. First, we are going to make this in a tabular form. We'll mention the number of plants as 0 to 2. Here we are having class mark. It is also called as mid value. Mid value or class mark is given by upper limit plus the lower limit divided by 2. Here upper limit is 2 minus 0 is 2 divided by 2 will give us 1. Same way, 2 to 4, there are 2 houses. Here the class mark is 3. Same way we have these values. Once we get the frequencies, we can find sigma fi, which gives sum of all frequencies. Then we will also find sigma fi xi. So sigma fi is 20, sigma fi xi is 160. Therefore, the mean is sigma fi xi upon sigma fi, we get it as 8 plants. This mean is also represented as x bar. In the next session, we shall see the different methods for finding the mean, and also we will make use of the formulae to find median and the mode. With this, I'll end today's session. Thank you.